See that? That's what we call in science an antacid tablet. It's made of calcium carbonate. Sometimes I take them if I ever drink too much fruit juice at night. I was using air quotes there. Anyhow, that's meant to neutralize your stomach acid, which is HCl. And we don't weigh solutions. Instead, we keep track of their concentration in molarity, which is moles per liter. Today, we're going to find out how many milliliters of your stomach acid, which is about 0.1 moles per liter, can be neutralized by this little guy. So let's go solve that problem right now. Well, hey everybody, hey, Mike here. We're going to talk about more stoichiometry, but this time we're going to do it with solutions. Like I said, we don't weigh solutions, we use their volume. So how do we relate back and forth between moles, which of course is the hub of every problem we want to solve, and solutions, which we measure in volume? We use molarity, which is moles solute. Now a solute is the stuff that's being dissolved, divided by liters, of course, of the solution, and you all know what solutions are. So let's show you how to use that real quick. So we got this problem. Bubba pipettes 25 milliliters of a 0.200 m NaCl solution. Now what I suggest you do to stay sane is when you see M, we're going to use the units to solve this problem. Go ahead and get rid of M. M is just to make things shorter, so it's just an abbreviation of moles per liter. That might help you. And that'll help show what we're going to do next. Do you multiply? Do you divide? How many moles of NaCl is this? Is the main game of the problem. Now if you like equations, that's fine. M times V equals moles. The problem with memorizing equations is it's dangerous because you sometimes memorize them wrong. And so what we're going to do here is, if you notice, if you take and write out the number in molarity, which is 0.200 moles NaCl, because you should always say what the moles are, times liter, divided by liters, that's what molarity is, you will see that if you just had the volume in liters, you would need to multiply to get moles. Of course, we don't have it in liters, do we? They were being tricky. Don't multiply in milliliters. You would just get units of moles times milliliters divided by liters. So we need to convert that to liters. And of course, there's 1,000 milligrams or milliliters in a liter. 0.025. And you'll notice if you do the equation molarity times volume, as long as the volume is in liters, sorry, I did a lowercase. You can do your L's whatever way you want. I did a combination there, which is confusing. But so 0.2 times 0.025, and the result is that is Barney pipetted 0.005 moles of NaCl. Fair enough? So, and you realize that's how we measure solutions. You wouldn't go and weigh any solution because they can have an infinite combination of concentrations. They're not like pure substances where we go measure their grams. And so now, folks, as you know, we've got to solve problems. And now we've got this concept map going on here. That's what we call in science a concept map. And so here, everything goes through moles, right? What we're going to do next is another more detailed problem where we're going to try to figure out how many liters of my or your or whoever's stomach acid can be neutralized by 500 milligrams of an antacid tablet. But you see, we're going to have to go in through moles and out through moles. And the way we get back and forth, as you know, you need to go to the periodic table to find out how many grams per mole something is. And what we need here to go from moles to liters is we need to know the molarity. So this comes from the periodic table, as we've done a gazillion times. This comes from what you read on the side of the bottle, which is usually very plainly labeled with its concentration in molarity. And so that's what we're going to do next, is a problem in stoichiometry, but a little twist on it, because we're going to get back and forth in between moles with grams and both volume. So let's go do that next. All right, here's a very practical example of what we were talking about. Let's say we've got an antacid tablet. And now I do want to point out to you that this is a reaction that happens in your stomach. If you take an antacid tablet, a lot of them are calcium carbonate. That's not bad for you. It's actually good for you. You could take these tablets as a source of calcium. They're 40% by mass, roughly, calcium. And so if you got an upset stomach because you drank too much fruit juice, then what you can do is you can take one of these and it'll neutralize the acid, and then you'll only be left to burp up a little CO2. Calcium chloride will dissolve, and you make a little water. This, by the way, is a form of acid-base reaction. It's not a redox reaction. It's called a gas-forming reaction. And if you dissolve this in HCl in a lab, you would see bubbles form on it. But anyhow, we've got a problem to solve, and that is how many milliliters of 0.100 molar HCl, by the way, just some trivia, that's the exact concentration of what the stomach acid is in your body, would be required to, how many milliliters of 0.1 molar HCl would be required to neutralize, there you go, I was kind of, to neutralize 500 milligrams of CaCO3, which is calcium carbonate. So here's what you're going to do. You're going to pop a tablet, you're going to chew it, you're going to swallow it, and then we're going to calculate how many milliliters of your stomach acid would that do away with. All right, here's a version without all those pesky words. So remember, the name of the game is how are we going to get to moles? First of all, I always find out that it's a pretty good idea right off the bat. Do yourself a favor, convert to moles, take the M out and make it moles per liter, so you can see, well, okay, I need to take that number and do something to it to get to moles, because it's not moles yet, it's moles per liter. That isn't moles yet, but you know what? It certainly could be if you recognize that 500 milligrams is 0.500 grams calcium carbonate. I can convert grams to moles, and this isn't a limiting reactant problem. This is now, here's one reactant, what's the other one? So it's not like they gave you two amounts and we have to decide which one's going to run out. So I think I'm going to run into a dead end. And by the way, you can also tell they want to know how many milliliters your stomach acid this is going to neutralize. So I'm going to go ahead and do the next thing, which is to go ahead and convert from grams to moles. And if you do a little bit of legwork with your periodic table, look along, grab your periodic table right now. We've done this to death, so I'm going to go kind of quick. 1 calcium is 40.08 grams. 1 carbon is 12.01 grams. 3 oxygens are 16 apiece. That's 48.00 grams. This bad boy is 100 grams per mole. Sorry, I got the higher math threw me there. 100.09 grams calcium carbonate equals 1 mole. So it looks like the first step I can take is to go ahead, here's a concept map again. Find out how many moles of calcium carbonate. The reaction tells us how to get back and forth from moles to moles HCl. There's a 2-to-1 in there. We got to figure out how to do that the right way. Now, 0.1 is what's going to get us from moles to liters and then to milliliters. That is our strategy, folks. Let's go ahead and do it. And I'm going to start with 0.500 grams. So 0.500 grams calcium carbonate. We're going to go ahead and use our conversion factor. Make sure that the units cancel, the ones that are supposed to cancel. 100.09 grams calcium carbonate. 1 mole calcium carbonate. Okay, now comes the tricky part. Not tricky at all, actually. Moles calcium carbonate, moles HCl. The whole reaction tells you just pick up the coefficient, put it where it belongs. 1 goes next to the calcium carbonate because there's 1 in the equation. 2 goes there. And now we could stop there and have moles, but I'm even going to go further, because the concentration is also like a conversion factor. So 0.1 moles per liter, that means 0.100 moles HCl equals 1 liter. And so here we go. I got to make sure I put in 0.100 moles HCl, 1 liter HCl. And then I ran out of paper, so let's stop after that step. Also, really good idea to make sure that all the units canceled that are supposed to cancel. Grams cancel, moles of calcium carbonate cancel, moles of HCl cancel. All that's left is liters of HCl, and then we got to make sure that we actually answered the problem, which is not liters but milliliters, but that's a trick that we can do pretty easy. 0.5 times 2 divided by 100.09 divided by 0.1. I got an answer of 0.0999 liters HCl. One more trick here. 1 liter HCl, 1,000 milliliters HCl. That's what they wanted. So times 1,000, 99.99 milliliters. About 100 milliliters. What's that? It's a little less than 4 fluid ounces. And so, I don't know. Sounds like a lot of stomach acid to me. I don't know how much your stomach holds. Ask a biologist how much your stomach holds or how much stomach acid is present in your stomach at any given time, but it just makes sense to me that that's not an outrageous figure there. Very good, folks. We've gone back and forth, and remember, it all goes through moles. You always got to go through Moleville, and now we just have one more way to get there. If it's a solution, you're not going to see a mass. You're going to see a concentration in molarity. And now you have now been armed with every kind of mole-to-mole problem to calculate the answer to something. And so, all right, go practice. Lots. Take care. Bye.